Okay, next up, Gabriella Levine, hardware engineer at Google X. Let's talk about some robots some more. Robot innovation, how robots are going to change the world. Let's do this.
It's awesome to be here today. Last Friday, I returned from after 3 weeks of being in East Kenya, working on things like looking at how conservation and education challenges affect the people, human and animal conflicts, and working on things like looking at how robots could potentially play a role in some of the world's most challenging subjects. I spent my time sleeping outside with Maasai warriors, killing sheep with my bare hands for dinner, going to local rural public schools with school children, and working alongside the Wildlife Anti-Poaching Squad to trap and release rhinos with GPS trackers. A lot of my work deals with looking at how we can scale up technological innovations in order to solve some of the world's most challenging problems that affect people all over. I work on a small team as an engineer called Rapid Evaluation at X, which is formerly known as Google X. Our mission is to come up with and prototype new solutions that could scale up and be called what we're calling them moonshot solutions. And I'll get into this, but a little about my background and my trajectory. It didn't start with an undergrad EE degree, but instead a wild and diverse path and a lot of self-taught learning. I have a passion for solving problems under pressure, and this might have led me to spend a few seasons as a wildland firefighter on a hotshot crew. I'd be based in the middle of nowhere with 20 other guys, no access to food, water, amenities, and for weeks on end, we'd be working out in the field. And I was exposed to a lot of big machines, like airplanes and helicopters, trying to help put out the fire. But really, what was the most efficient was just the ground crews, us working, digging lines slowly. And these inefficiencies got me interested in thinking about how some automation and machines could play a role in disaster relief. During my time off, in my off-season, I ended up teaching myself about coding, teaching myself a little bit about how to prototype robots and basic circuits, and ended up building a whole series of snake robots. The idea was that these little robots could go into the wild and do things like search and rescue and explore harsh terrains that people couldn't even get to. This passion for environmental sensing robots eventually led me to help form and grow a company, now based in Hong Kong, manufacturing and making sailing robots that actually move on the water like a snake. They're called Prote, and the purpose is that they could drag a heavy payload behind the boat, things like sensors and this oil-absorbent polypropylene tail, to actually clean up oil near oil spill sites. The boat's meant to eventually be unmanned and sustainable so that it could go all over and be operated from anywhere in the world. I worked a lot in the lab, building and testing and hacking things together, but then out in the field, working with global communities to do things like map radioactivity off the coast of Fukushima, monitor plastic trash in the middle of the Pacific Ocean, and work with fisheries in Ghana to understand their relationship to the oil industry. So this passion for addressing problems at scale has led me to X, and so here I am. At X, we say that a moonshot is the intersection between three things. You start with a problem, a huge problem, and then there's a radical solution that could solve that problem better than anyone's ever managed to do. Then there's a breakthrough tech that actually makes this solution possible. So it's sort of like a place where all these sci-fi technologies are brewing under the hood. One moonshot aims to address the problem that over 1 million lives are lost each year due to traffic accidents. 93% of those are caused by human error. So the radical solution is a car that could drive itself, and the breakthrough tech is combining pre-map data with live sensor data so the car could actually see the external world. Using a combination of LiDAR and radar and other sensors, the car could actually see obstacles big and small that the human from the driver's seat couldn't even possibly see. Last year, we released a first prototype built from the ground up in order to autonomously get from point A to point B with just the press of a button. Besides safety, this also allows people to have more family interaction time while in the car. as well as allowing people who never before were able to drive themselves be able to get places alone, like this visually impaired man. Another moonshot aims to solve the problem of more seamlessly transporting items and getting that last mile of delivery, and it's called Project Wing. Project Wing is a system that uses self-flying vehicles to deliver items in minutes. So if you're in rural places, in the forest or East Africa, there's a natural disaster and you need medicine, vaccines, and the roads are poor, no problem. If we need beer later tonight, ASAP, no problem also. So these are the types of radical solutions that X is trying to make a reality. X is composed of all types of people and working on many diverse teams, designers, psychologists, engineers, aerospace engineers, makers, all coming together to try to make it a safe place to take risks and a safe place to fail. On the rapid evaluation team, our mission is to launch and prototype new moonshots for X by thinking big, embracing failure, and then fostering an attitude of fearless exploration. But we say that rapid evaluation, it's as much of a process as it is a team. So we love problems, and we're always looking for new ones. And then we're taking all the problems and coming up with hundreds of solutions. We're killing 95% of our ideas, but then coming up with more and doing a lot of de-risking in the lab, but then also going out into the world and working with people across the world to understand both their creative solutions as well as the problems that others are dealing with. I do a lot of my prototyping in the design kitchen, which is our digital fabrication and prototyping shop. I do electronic prototyping, wood fabrication, metal fabrication, off-the-shelf parts, and I take them apart and hack them back together. And I'm actually known on my team for breaking the most things, because I build a lot of things I don't know how to do. And it's a point of pride now. So whatever we do along the way of an investigation, we're trying to poke holes in it and make it fail. So this idea of failing fast really has to do with us embracing constructive failures. And we like to say that as the project continues, there's more people working on it, more money, more love for a project, the cost of failure is higher. So this is the sweet spot for rapid eval, early stage idea investigation and risk reduction. So we're doing as much as we can early to see whatever we can do to make something fail and start to work on something else. There are a lot of projects I'm working on and investigations that I can't talk about, but one that I really admire and support that started before I arrived, it's called Project Loon, and it aims to deal with the fact that over half the world lives without access to the internet. And the solution for this really addresses the attitude of rapid eval. So the solution is balloons that fly in the stratosphere are long-lasting, maneuverable, and could actually deliver internet to those parts of the world without it. But the biggest question here was a tech one. Can we actually talk from the ground to the stratosphere to a balloon via Wi-Fi? So the first engineers went to Amazon, got a off-the-shelf Linux computer, a Wi-Fi dongle, and an off-the-shelf balloon, and packaged everything up into a cardboard box with duct tape and a lot of hot glue, which is key to my prototyping and everyone's. So in under $400, just 1 month later, they launched the balloon into the air, into the stratosphere. They were following it around, driving around in the car, trying to establish a ground-to-air connection. And it worked. They were able to see Wi-Fi packets being exchanged. As always happens, there were many unforeseen challenges that came up. How do you prevent the balloon from getting a hole in it? How do you keep the electronics charged through the night? They kept engineering, and for each problem, they were able to create solutions, and they weren't able to make the project fail. 2 years later, the balloons have flown for over 17 million kilometers in the sky, for over 100 days at a time. And by 2017, they aim to create a ring of connectivity around the globe by partnering with local telcos to create a commercial product. So when I'm reflecting on my past few weeks in Kenya, one instance comes to mind, and that was when we trapped a female pregnant rhino and released her after gluing a GPS tracker into the horn. It was emotional and traumatic, and I could actually feel the fetus while she was lying down in the stomach. It makes me wonder, so it took half the day, almost 40 men with machine guns, a helicopter, an airplane, and a vet with a dart gun. So I really got to think, can't some of the technologies that we're developing here, things like drones and sensors, and the cool things that we're doing right here in California, scale up inexpensively and be applied to lessen the stress on animals and humans, and do things like prevent poaching and other illicit underground activities? So whatever personal moonshots you're working on, however big or small, I urge you and us all to think critically, how could some of the cool things we're doing right here scale up and affect a global community? Thank you.